Welcome to the session. Before moving on to exercise 7.9, let us see the introduction, that is fundamental theorem of calculus here. And here they have given this upper limit is b and lower limit is a, and the function we have denoted to be f of x. For that, the area of the function is represented by capital A of x. Therefore, a of x is equal to integral. Here they have split it into two integrals, that is a to x and x to b. So they are a of x they have written as a to x and f of x into dx. Based on this, they have defined two fundamental theorems. That is, first fundamental theorem of integral calculus. That is, when you differentiate the first function, when you differentiate this a of x, this integral will go off. So you will get a dash of x is nothing but f of x. The next one, if it is a continuous function defined on the closed interval a comma b, and capital F is the antiderivative, that is the differentiation of it. When you after integrating, when you find out that is the antiderivative, when you find out the antiderivative, you will be getting, that is the upper limit and this is the lower limit. You will be writing f of b minus f of a. That is, when you integrate a certain function, for applying the limit, you will be writing the function with the upper limit minus the function with the lower limit. That's what they have given in second fundamental theorem of integral calculus. That's what we are going to apply for integrating a definite integral. Theorem 2 tells us integral a to b f of x dx is equal to value of the antiderivative f of f at the upper limit b minus value of the same antiderivative at the lower limit a. Just go through this and let us move on to exercise 7.9. The first question is integral minus 1 to 1 x plus 1 into dx. Now, for your easy convenience, what you can do is, you can separate the limits, separate the integral. When you separate the integral, you will be writing minus 1 to 1 x into dx plus integral over minus 1 into 1 to 1 dx. When you integrate this, what you will be writing, this is when you are applying x power n into dx formula, you will be writing x power n plus 1 divided by n plus 1 by applying that. When you integral over x dx is nothing but x by 2. So, you should write upper limit and the lower limit here. See here, when you are integrating x dx, what you will get? X squared by 2. If there is upper limit and lower limit as minus 1, towards the right hand side, you should write the lower limit bottom and upper limit here. And here dx, when you integrate dx, what you will get? X. So write the upper limit and the lower limit. According to the second fundamental theorem of calculus, what I told you to write? Upper limit minus lower limit. Therefore, substitute the upper limit here. When you substitute, what you will get? 1 square divided by 2. Upper limit minus lower limit. Therefore, upper limit when I substitute, I will get 1 square by 2 minus lower limit is what? Minus 1 the whole square. Therefore, minus 1 the whole square by 2, then plus upper limit 1 minus lower limit. Lower limit value is minus 1. Whenever integer, it should be very careful. Therefore, 1 by 2 minus 1 by 2. You will be getting 1 by 2 minus 1 by 2 is nothing but 0. Here it is 1 minus of minus 1 is 2. Therefore, it is 2. Therefore, 0 plus 2 is nothing but 2. Therefore, write the value of the integral. The next question. Integral 2 to 3 1 by x dx. Therefore, integral over dx by x is nothing but log x, log mod x plus c. Whenever you are substituting the upper limit and the lower limit, you won't be writing the constant of integration, since they have given for a certain area where we need to integrate. So this is nothing but log x and upper limit, lower limit. You should write upper limit and lower limit here. After that, you should substitute upper limit minus lower limit. Therefore, in the place of x only, you are going to substitute upper limit. Therefore, log 3 minus lower limit is log 2. Therefore, this is of the form log a minus b, that is nothing but log a by 2. Therefore, log of 3 by 2. The next question, I equal to integral over 1 to 2 4x cube minus 5x square plus 6x plus 9 into dx. This is the homework sum. Just I will explain how to do. First thing, separate the integral and take the constant outside. After that, integrate and apply the upper limit minus lower limit. Just I am showing the steps. Just see, and this is the final answer. Now let us move on to the fourth sum. I equal to integral over 0 to pi by 4 sin 2x dx. Integral over sin 2x dx is what? Integral over sin x is minus cos x plus c. Here, whenever this indefinite integral, you will be adding constant of integration. If there is upper limit and lower limit, you won't add the constant of integration here. Therefore, if integral over sin 2x is nothing but what? Minus cos 2x. What is the coefficient of x2? Therefore, you need to divide by 2. So, you are writing here and applying upper limit and lower limit. Therefore, upper limit, in the place of x, you need to substitute upper limit minus lower limit. Since for our convenience, what you are doing is you are taking the constant and the negative sign outside. Therefore, minus 1 by 2, when you take it outside, upper limit is, you will be having minus 1 by 2, I am taking outside, cos 2x 0 to pi by 4. Therefore, upper limit will be cos 2 into pi by 4 minus cos 2 into 0, lower limit. Now when you simplify this, you will be getting 2 cos pi by 2 minus cos 0. Cos 90 degree is nothing but 0, cos 0 degree is nothing but 1. Now when you simplify this, you will be getting half. The next one. The next one is also homework, so just go through it. Go through it and write the final answer. And one more thing, this same as sin 2x. Here sin pi value is nothing but 0. Sin 0 is also 0, therefore the integral is 0. The next one, sixth one, integral over 4 to 5 e power x into dx. Now when you integrate e power x dx, you will be getting e power x plus c. Therefore I have written e power x, upper limit, lower limit. This x is nothing but the x takes the value of 5 and 4. Therefore upper limit is e power 5 minus lower limit is e power 4. So you have taken e power 4 outside and write the final answer. The next question, tan x. In the third or fourth exercise, you have learned what is the formula for integral over tan x. Therefore, integral over tan x is nothing but log of modulus of secant x, or write the upper limit and lower limit. Now x value is, substitute the value of x as upper limit minus lower limit. Therefore, you will get log of secant pi by 4 minus log of secant 0. That is 45 degree. Secant 45 degree is nothing but root 2 and log secant 0 is nothing but 1. Log 1 value is nothing but, keep it in mind, always log 1 value is 0. So it is 0. Now this root 2 can be written as 2 power half. So according to the property log x power n, it can be written as n into log x. Therefore you can write it as half into log 2. After that, write the final step. The next question is also the same way, applying the formula integral over pi by 6 to pi by 4 cosecant x dx. Integral over cosecant x dx formula is log of modulus of cosecant x minus cot x. Therefore, you have integrated and you have written the formula. After that, you are going to apply the upper limit and the lower limit. Therefore, upper limit is pi by 4. So, when you apply upper limit, you will get log of cosecant pi by 4 minus cot pi by 4. Upper limit is over, minus lower limit is pi by 6. In the place of x, you need to substitute. Therefore, log of cosecant pi by 6 minus cot pi by 6. After that, substitute the value and write. Just go through the steps and write the value properly. The next one, integral over 0 to 1 dx divided by root of 1 minus x square. Now what formula is this? This is nothing but sine inverse of x. Directly the first exercise itself you have written. You can, no need to write the step. You can write this as sine inverse of x. This is the formula, 0 to 1. What is the upper limit? Upper limit is 1. Therefore, sine inverse of 1 minus sine inverse of 0. What is sine inverse of 1? Pi by 2. Sine inverse of 0 is 0. Therefore, integral over 0 to 1 dx divided by root of 1 minus x squared is nothing but pi by 2. The next one, by seeing the question itself, you can tell what is the answer. Integral over 0 to 1 dx by a1 plus x squared is what? Think and tell. As I told in the previous video, integral over 0 to 1 dx divided by 1 plus x squared is nothing but tan inverse of x. Apply the limits 0 to 1. What is the upper limit? 1. Therefore, you will be getting in the place of x only, you are going to substitute tan inverse of 1 minus tan inverse of 0. What is tan inverse of 1? It's pi by 4. What is tan inverse of 0? 0. Therefore, your result is pi by 4. The next question. Everything is the formula which you have learnt. Now, integral over 2 to 3 dx divided by x squared minus 1. Now, this is the form integral over dx divided by x squared minus a squared. Now, what is the formula for this? It is 1 by 2a into log of x minus a divided by x plus a. See, did you remember? I think so she's written. Yes. It is 1 by 2a into log of x minus a divided by x plus a. So, in the place of a, what is there? 1. So, 1 by 2 into 1 log of modulus of x minus 1 divided by x plus 1 plus 1. Here, since there is a limit, no need to apply c here. Therefore, 2 to 3. Now, as I told already, if I have constant and a negative sign, you can take it outside and apply the limit. Upper limit 1 by 2 is common for both upper limit and lower limit. Log of upper limit is 3. Therefore, 3 minus 1 divided by 3 plus 1 minus lower limit is log of 2 minus 1 divided by 2 plus 1. 3 minus 1 is what? 2. 3 plus 1 is 4. Then you simplify, you will be getting 1 by 2. Here you will be getting 1 by 3. Therefore, log of 1 by 4 minus log of 1 by 3. Log of a minus log b. That is log a by b. Therefore, you will be getting 1 by 2, when you simplify this, you will be getting 1 by 2. 1 by 2 divided by 1 by 3. When you reciprocate, that is 1 by 2 divided by 1 by 3. When you reciprocate, you will be getting 3 by 2. Therefore, 1 by 2 into log of modulus 3 by 2. The next question, it is in exercise 7.3, you have learned this cos squared x. Integral, whenever it is a cos squared x, I told you to apply cos 2x formula. Therefore, what is cos 2x formula? 2 cos squared x minus 1. Therefore, cos squared x will be 1 plus cos 2x by 2 into dx. So, what you can do, you can take 2 outside, separate the integral, integrate. So, 1 by 2 into integral 0 to pi by 2. 1 by 2 I have taken as common. 1 by 2 you have taken as common. Therefore, separate the integral. It is 1 by 2 into integral over 0 to pi by 2 1 plus cos 2x when you take it outside, when you take 1 by 2 outside. After that, separate the integral. When you separate the integral, you will get 0 to pi by 2 into dx plus integral over cos 2x into dx. Now, when you integrate when you integrate dx, what you will get? When you integrate dx, dx. When you integrate cos 2x, it is sin 2x by 2. And apply the upper limit and the lower limit. Therefore, upper limit minus lower limit. For the first apply upper limit. Upper limit is pi by 2 plus sine 2 into pi by 2 by 2. These two terms are upper limit. Minus lower limit is 0 plus sine 2 into 0 by 2. After that, find out the value. It is sine pi by 2. Sine pi by 2 is nothing but, that is not sine pi by 2. It is sine pi divided by 2. What is the value of sine pi? It is 0. And here, sine 0 is also 0. Therefore, this value becomes 0. This value is also 0. Therefore, it is pi by 2. Therefore, 1 by 2 into pi by 2 will become pi by 4. Thank you, students.